The final topic we'll talk about is stress, anxiety, and depression. Many of the interactions we observe between the gut microbiota and the brain involve stress in some form. Mice, chickens, and even primates that are put into stressful situations show substantial changes in their gut microbes. You can see in this figure, produced by Bailey and Co. in 1999, that as infant rhesus macaques show more stress-indicated behaviors, the relative abundance of lactobacilli, often considered to be a beneficial microbe, tend to drop. Another study by Pseudo in 2006 in mice has shown the reverse relationship, where stress actually increases the amount of lactobacillus in mice. And then germ-free mice that are raised without any microbes of their own in a germ-free bubble turn out to have a stronger stress response when they're restrained than do mice with a normal gut microbiota, suggesting that your normal gut microbes might actually increase your resilience to some kinds of stressful conditions. Moving on to depression. Depression is a major cause of disability in the United States and even in much of the developing world. In fact, the National Institutes of Mental Health estimates that by 2030, depression will be the leading cause of disability-adjusted life years, making it an especially important disease to tackle. We already know that depression is linked to the immune system, and because microbes can influence and regulate immune responses, it makes sense to think that by manipulating the microbiome, we could treat or even prevent depression and its relative stress and anxiety. A fascinating study in mice, conducted in part by Chris Lowry, showed that the soil bacteria Mycobacterium vaccae can decrease anxiety in mice and can even help them cope better with stress. This could be a model for treating anxiety disorders like PTSD in humans. Who knows, one day we might even be able to vaccinate against depression and against PTSD using microbes. Graham Rook, Chuck Rezan, and Chris Lowry proposed exactly this idea after seeing evidence from studies in mice that it just might work. In fact, a study by Masadi and colleagues showed that people taking probiotics with lactobacillus and bifidobacterium, again, two kinds of beneficial bacteria that are especially prevalent in the infant gut and are involved with short-chain fatty acid production, showed substantial reductions in anxiety symptoms. So in conclusion, we're only beginning to understand the connections between and the influence of the gut microbes on the brain. However, already there's evidence that beyond diseases, our gut microbes can have an effect on the formation of our memories, our emotions, and even on the way we make decisions. So therefore, just like our brain, our gut microbes are part of what make us human, and we cannot neglect their input into our behavior, our moods, and perhaps even our neurological health.